Hello, everyone. This is Wei from the SciLifeLab and KTH University in Stockholm. It's a great pleasure to give this talk during the I2K conference. And today I'm going to introduce you a new platform called Hypha for scalable data management and AI model serving. So in order to build next generation bioimage analysis tools, which mainly powered by AI, and massive data set, here's a list of requirements which is super important to take into the consideration when building these different tools. Among them, scalability, which means we need to handle large data set and perform GPU computation, which is very heavy. And we need to design usable interface for non-expert users, enable flexibility on different data types and interactivity in order to perform, for example, interactive annotation. And then there's a privacy issue for some of the especially biomedical data, which we need to perform some, for example, federated learning. So what I also want to point out, desktop software do not scale conventionally. Because of, in terms of hardware, its lack of storage. Because of laptop, for example, it has a lot of storage or doesn't even have a GPU for AI models. And on the software side, we have this, the traditional desktop software has this tight couple between UI and computation, so makes it easy. Makes it hard to run it on the, for example, run in the cloud environment. And then new platforms such as tablet and mobile phone, which has 5 billion users, for example, which is important to also take into consideration. So what we need is actually a cloud native solution, which handles data and computation in the cloud. And we can only use, for example, desktop software and also the browsers as a client for performing visualization, right? And then, but doesn't do the heavy computation. So this is what we have in mind. With that in mind, we designed this platform called Hypha. So Hypha itself is a Python library which does this bidirectional remote procedure calls. So it's a communication hub. It handles user authentication, for example. It separates different applications into virtual workspaces. And then it handles object storage such that we can use S3, for example, to manage massive data set among different users. And it also handles, for example, we have this server-side browser apps, which allows us to run lightweight arbitrary code execution from the user. It can also scale horizontally by adding more node to the cloud environment when we have more users, for example. On top of Hypha, we built this Hypha app engine. So it's basically building on top of a Kubernetes, which is a container orchestration environment. So basically we have the S3 server, which is one Docker container. And then we have the Hypha, and there's also Triton inference server, which we use for hosting and serving AI models. And we can also support custom containers. And we have a lightweight browser workers, which allows to run arbitrary code from the user, such that enables kind of orchestration between different services within the cluster. Through this RPC connection, and we also support HTTP connection. So the users with, for example, a third-party worker, which is an application running in another Docker container outside the Kubernetes cluster, for example, it can also connect to the Hypha app engine. And you can use desktop software as a client and also web client, such that you can talk to the Hypha app engine. Hypha app engine is actually designed for hybrid cloud computing for data management and AI model serving. What we have in mind is that in a scenario where you have the public cloud, right? Here we can have the Hypha here, Hypha app engine running in the public cloud. and which can interact with AI model repository, for example, and also those public data repository, for example, the BioImage archive or Zenodo, for example. We can download the data and process them. But what more interesting is that for many of the users who has their institutional IT who can potentially host this private cloud instances, such that you can have a Hypha app engine, for example, running in an institutional scale or universities, or even in a lab on a workstation, for example. And then what we have in mind is that using this kind of infrastructure, we can potentially power the next generation AI augmented microscopy running models in real time, or just perform conventional image analysis task with the web or desktop apps. And then, but all these are as a client. So it's gonna make it much easier for the developer to design this. So this is just a quick tour to the Hypha application. I will quickly go through this notebook just to give you a taste on how Hypha works. And so this is a Python library we designed to interact with the Hypha's app engine. For example, you can just connect to the server, and then you can, within the app engine, you have a list of services which the user or the other application can expose, which you can use or access. There's a S3 service which we can get, and then, for example, you can generate this kind of authentication tokens such that you can use arbitrary S3 client to upload data, download data, and then, or you can interact with it through the Hypha RPC, and you can download the files. So one important thing I want to show is that we have this Triton client, which allows us to interact with the Triton inference server. And this essentially allows us to perform AI model serving, right? So here, what I'm showing you now is that it's in the Triton inference server, we have deployed this cell pulse model, and with this kind of a few lines of code, and you can just send a NumPy array to the Triton inference server and obtain the result as you see here, right? So there are other features. For the sake of time, I will just skip. So with Hypha, we can enable easy building of AI platforms for the masses, for the users, and with also especially interesting when we combine with these two other projects which we have been working on. One is the ImageJ, which is web application, allows to build us to run web-based plugins to interact with the Hypha server, and the other one is the BioImage Model Zoo, which is basically a repository of AI models, and we can connect this data model repository with the Hypha app engine to allow performing AI model serving. So, and we wrap all this together, which made a new project called BioEngine, which is an infrastructure powered by Hypha, especially for bioimage analysis. So this is how it looks. The BioEngine is essentially a set of Docker containers. The important part is this Triton inference server, and which connect to the BioImage Model Zoo, such that we have all the models available. And then it's connect to Hypha, and Hypha provide a communication channel to allow it interact with these different models. And on the client side, the user can use desktop client, Elastic, Napari, ImageJ, QPath, and all these different software. They can talk to this BioEngine and perform server-side computation, especially for those AI models. And on the client side website, we have ImageJ and Jupyter Notebook, which you just see in the previous slide. And the important feature is that there's no installation required. You just open the web browser and then you interact with this server and process your data. And we provide this kind of flexible deployment options, either in the public cloud or in the private cloud. So, and there's another hands-on workshop for the BioEngine at I2K, and I have posted this. You can feel free to watch this video. And just also want to mention that I have been making this demo video about AI-assisted bioimage analysis, which use this powerful AI natural language OpenAI models called the GPT-3 for natural language processing. The cool thing about this tool is that you can use English and then use this model called Codex built on top of a GPT-3. It can generate Python code such that we can use English to generate Python code to perform bioimage analysis task. Yeah, feel free to watch this video. So in conclusion, Hypha is a scalable data management platform and also for AI model serving. We use it to power the next generation bioimage analysis platform. This is the system called Hypha App Engine, and we also made a use case, which is the BioEngine. It's a Hypha powered platform designed for handling bioimage analysis tasks with AI models, and this is especially developed for connecting to the BioImage Model Zoo, which allows test run through the BioImage Model Zoo website. So yeah, so the work I have been doing is mostly carried out in the self-profiling group at Emma Lundberg's group in SciLifeLab. Many of the projects I have been working is open source project driven by community members. For example, ImageJ is powered by, is supported by key members, including Florian, Martin, Craig, for example. And there's another, the BioImage Model Zoo project is a collaborative effort powered by many other teams, including the ImageJ, there's EBI BioImage Archive team, Fiji, ImageJ, Elastic, ImageJ, Zero Cost, and all these different community members. We have been working together actively and contributing to the work which I have been presenting here today. So thank you very much. Thanks for your attention. Yeah, I guess we will have a chance to have this Q&A session later during the conference. Thank you.